This is review number 5, basic exponents and logarithms. There is a lot on this review, a lot of like nitty gritty details. So make sure you take it slow and ask if you have any questions. The expression 1 over x to the third squared is equivalent to what? So what you're doing here is you're giving this exponent to both the numerator and the denominator. So 1 squared is just 1, and this is a power to a power, so you multiply and you get 1 over x to the 6th. Now this answer is the best answer because the exponent is positive, but for multiple choice purposes, there is no answer that looks like that. So what they want you to recognize is this and this are equivalent. Remember, if your exponent is negative, you put it on the other side of the denominator. So the expression x to the negative 1/4 is the same as what? First thing I'm going to do is get rid of my negative because I don't like them. So I'll put it in the denominator. Now remember, when you have a rational exponent, that's an exponent with fractions, the numerator is your power. The denominator is your root, like square root, cube root, fourth root. So I would write this 1 over fourth root x to the 1, which is number 3. And question number 3, the radical expression cube root of 135, x to the 4, y to the 8 can be simplified to, so I'm going to split this up. First, I'm going to do cube root of 135. And then I'm going to convert my radical from my variables into rational exponents. So 4 over 3 and y 8 over 3. Maybe we can get away without dealing with that to get our correct answer. So when I simplify x to the 4 over 3, you want to break it up into 2 pieces where one, the fraction will cancel out. So this becomes x to the 1, it's a 1 over 3. And then this becomes radical cube root of x to the 1. Now for my y, I'm going to do y to the 6 over 3, and then my leftover is 2 over 3. So 6 over 3, that simplifies to y squared. Why do I keep messing up these denominators? 2 over 3. And then you have cube root of y squared. Make sure your simplest radical form is when your numerator is smaller than your denominator. So if I put my variables together, I end up with x, y squared, cube root x, y squared. So let's see if we've got any of those. Should I do that right? Yes, look at here. Xy squared, xy squared. That is the only one that has those numbers. But because we are reviewing, let's practice that. So we have to split this up into 2 cube roots that multiply to 135. One of them has to be a perfect cube, and it's 27 and 5. Cube root of 27 is 3, and you can't take a cube root of 5. So that's why the 3 goes in front and the 5 stays inside. These are very tricky. Make sure you practice them on Delta Math. Number 5. The expression square root of x to the 5th over fourth root of x to the 7 can be written for x is greater than 0 as, remember this part right here? That just means the denominator can't be equal to 0. So for your purposes, ignore it. We are going to simplify this crazy expression. First thing I'm going to do is get rid of the radicals, and I'm going to rewrite both the numerator and denominator just with rational exponents. So square root of x to the 5th can be written as 5 over 2. And fourth root of x to the 7 can be written as x to the 7 over 2. So now we're going to subtract our exponents because we're dividing with common bases. So this becomes 5 over 2 minus 7 over 2. So this is x to the negative, hold on a second. Oh, rats. Sorry, folks, I messed that one up. Hopefully you guys noticed. It's not 7 over 2 here. It's a 4th root, so it's x to the 7 over 4. I thought that was a little too easy. We're still subtracting. So we're doing 5 halves minus 7 fourths. So you can either get a common denominator when you combine. I just put this into my calculator and I got x to the 3 over 4. This is simplest exponential form. Over here, they want us to choose from radical form. So it's the 4th root of x to the 3rd, which is option number 1. I'm going to stop the video. You can turn the page, try some problems, and come back and check on the next video.